Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hi everyone, welcome to today's session of Dynamic Programming Series. Very pleased to see you all here. So before we begin, can I please get a quick confirmation if my voice is clearly audible and also if my screen is clearly visible? Let me just share. Yeah. And also let's just wait for a couple more minutes so that rest of our friends also join, and then we shall be starting today's session. All right. Hello, Nikaj. Hello, Nix. Thanks for the confirmation. So we are covering dynamic programming. All right. And today what we are going to cover is the topic DP on trees. Okay. We will see how we can use the dynamic programming questions for the problems that are involving trees concept. Okay. And how many of you have attended all the sessions that have been taken previously? Please give a quick +1 in the chat section. All right. Thank you. Next. I hope all the concepts were clear to you. Okay, that's great, Himanshu. Hi, Shishir. Welcome to the session. All right, that's great to know that concepts were clear to you. Okay, so we are good to go. So let me just. All right. So today we are going to discuss the problems that are based on DP on trees. Okay, what do I mean by DP on trees? As we know, we have trees that we deal with, right? The normal binary trees that we have, or any kind of tree that we have. Okay, but then there are some problems that you can solve with the help of applying DP on those trees, right? So that is going to be our aim for today. So the kind of questions that we are going to discuss is, the first question is going to be diameter of a binary tree. Okay. Now, for before we start solving the question, first of all, let me explain you what do we exactly mean by diameter. Okay, so anyone in the chat section would like to tell me what is the diameter of a binary tree? Like, what is its definition? You can write any answer. There is no anything such as correct answer or wrong answer. You can write whatever you feel like writing, and then we will discuss over it. Okay. All right. So basically, let me help you with that. All right, next, the definition that you shared with us, the length of the longest path between any two nodes in a tree, that is not exactly any two nodes. That should be, just a second. That should be between two nodes that are leaf nodes, right? Okay, so means a diameter should start from any of the nodes that are the end nodes, right? I mean, it need to be the last node of the tree. Only then you can say that it is a diameter. Okay. So what the diameter, that is also known as the width of binary tree. So what it exactly is, it is the length of the longest path starting from one of the end nodes to another end nodes, right? So in this tree that I have drawn here, if you will try to find out the diameter, that you will see that if we consider this node, then this, this, and this, right? So yeah, so it is 1, 2, 3, 4, 5, 6, 7, 8. The diameter of this node is going to be 8. All right. Sorry, the diameter of this tree is going to be 8. Okay. So that is what the diameter means. You need to find out the maximum number of nodes that are there between the end nodes, right? Okay, so now we are clear on this question. So the question demands us a binary tree is given to you. You need to find out its diameter. Okay, so first of all, let me specify how we can use DP here. Okay, how DP. First of all, any question, generally whatever questions we solve, if it is based on a tree, what is the one of the most common approaches that we use to solve the questions that are based on trees? Like most of the trees question, you can say that around 50 to 60% of trees question are solved exactly. Next, that's the correct answer. We use recursion. Okay, and as I have said, recursion is the parent of DP, right? Nikaj, yeah, post order, that is a traversal method. So the method that we use basically to solve the tree question is recursion. Okay, so you will find out that whenever there are questions that are based on trees, we kind of need to use recursion. Why recursion? Because we need to repeat the same process for every node of the tree, right? Whatever nodes are given to us, we need to do the similar process for every node. That's why we use recursion. Okay, so now as we know that recursion is the parent of DP, right? So that is the first intuition that we get on how we can solve this question using DP, right? Because it uses recursion. Secondly, as the question was, we need to find out the diameter of the tree. Okay, so let us suppose this is our target tree that is given to us and we need to find out the diameter. So for finding out the diameter, there can be multiple instances. For example, either this can be the diameter of the tree, right? Only this portion, or either this can be the diameter of the tree, right? So basically what is happening here is we are making choices, right? That whether we are going to involve a current, let us say this is our this is a node, okay, on which we are performing operations. So we are deciding, okay, that whether this current node is going to be involved in diameter or not, right? There is this decision making. So, and also optimality is always there. We are finding here the max, right? Max distance between two nodes. Okay, so based on these things we can say that this question can be solved with the help of DP. Okay, so now let me explain the approach that we are going to use to solve this question. Okay, so okay, is that part clear, how we can use DP to solve this and why DP is used? Was I able to convince you all for that? Okay. So as we need to find out the maximum sum, let us say we are creating here a function, sorry, the maximum distance, okay? So let us name it as solve, and the parameters that we are passing to that function is root and in ampersand res. What is res? Res is the variable that will be storing the answer, okay? You can initialize the res inside the main function, okay? The function name that will be given to you, you can initialize res with 0, right? And then you can pass it to this function, okay? And always remember, whenever you are passing it, pass it by reference, okay? Because the value of res will be changed in every iteration, and we need that value to be reflected in the main function, okay? So that's why make sure that you are passing here by reference, right? So now it is going to be a recursive function, okay? That we are clear about, that we will solve this question with the help of recursion. So now, if it is a recursive function, then what is the first thing that comes in a recursive code? And whatever that thing is, what will be that thing for this function? Yeah, exactly. That's base case. And what is going to be the base case for tree-based questions? All right, Nikaj and next. Nikaj, I think that you missed out some lines, but I'm sure you were about to write the correct answer. Next, thanks for the correct answer. The base case for this question is going to be if not root, that is if root is null, then we will simply return 0. Right, that will be the base case, okay? Now we are, what we are going to do is, whenever there are questions based on trees, so what you need to find out is, you need to find out the answer for the left subtree, answer for the right subtree, and then you need to do the comparisons, right? That's how the question works. Like if there is a node, you need to find out that what is happening towards the left side of the node, what is happening towards the right side of the node, and then you need to do the comparisons and return the required answer. So for that, what we are going to do is, first of all, we will calculate for the left part, okay? So left part will be, we will call the solve function for the left subtree of the root, okay? And we will pass res, and then we will be calling for the right subtree of the root, okay? And we will pass the function, okay? All right, so these two steps done. Now let us move towards our third step. Okay, all this we are writing inside a recursive function. Okay, keep that in mind. Now, what is going to be our third function? So we have value of L, we have value of R. Let us say this is your tree. Okay. This is your root. Okay. And let us say this is our working node. Okay. The current node that we are working on. All right. So there can be two instances. What can be one thing? That is that, you will calculate its left part. This is the node that, this is our target node right now. Okay. So you will calculate its value for its left subtree. You will calculate its value for right subtree. Okay. Now we need to find out the diameter. So there can be two cases. First case, that diameter will pass through this node. Okay. You will traverse like this. Cool, you are involving this node in calculating the diameter, right? So in that case, what we are basically doing is, you are basically taking the value from its left subtree, you are taking the value from its right subtree, and you are simply adding 1. Why 1? Because this node is also involved, okay? So whatever is the number of nodes in the left subtree plus whatever is the number of nodes in the right subtree plus 1, okay? That is going to be one of the possibilities when you are involving this node, right? Now, second possibility, what it can be, that when this node is not involved, okay? Let me erase this. So this was my node. Yes, we will be keeping track of max as well. Let us first of all see that what are the possibilities that we have, okay, and then we will compare the max value, and obviously as you said we will keep the track of max as well, okay. So this is our current node, okay. So one thing, the first case as I discussed, you will calculate the value from the left subtree, you will calculate the number of nodes in the right subtree, and you will add 1 to it to get the diameter, okay. Second thing, it can be that this node is not becoming the part of a diameter, like this node is not the center root of the diameter, okay. In that case what will happen is you will find out the value of left and right by using this, and then what you will do is you will find out the maximum of left and right, okay, whatever maximum will become, and then you will add one in it, okay. So what you will do it, let us say in left it is coming 3 nodes, in right it is coming 5 nodes. So what you will do, you will consider this right subtree and you will add one y for this current node, okay. So you will the 6 is the answer, right? So you will pass this to the root, okay. So in this way it will get passed. So these are the two cases that we have, right? So to keep track of these two variables, what we are going to do is we will create a temporary variable. It will hold what? It will find out the maximum of L and R, and it will do a +1 in it, right? It means what? You will take the maximum from either of the left subtree and right subtree and add this node to it, and then you will move ahead. Okay, you will tell the root that, okay, this is the maximum path, that is 6 I'm getting from here. You can use this 6 value to find the maximum diameter, right? So we will store this, and then we will be having our maximum answer. That is going to be, let us say we have an answer variable here, okay, yeah, that you will store as maximum of temp or L plus R plus 1, okay. These are the two comparisons that we are making. This is when the current node is not involved in the diameter, and this is when the current node is involved in the diameter, okay. So in these two cases you will find out whatever the maximum value you are getting, okay. In the rest you will store the maximum value, okay. And then once when that part is done, towards the end what you need to do is we will simply return temp. Why temp we are returning? Because temp is the value that we are going to pass to the root node, right? Means whatever temp is storing, what temp is storing maximum of L R plus 1, okay. It means either from this part, either from this part, okay. And it is getting passed, okay. It will not get passed to the root when you have involved this node in calculating the diameter, and this was the complete diameter, okay. In that case root is not getting involved, right? But when you are using any one of the subtrees, then in that case root will get involved. So that's why we are passing the temp. At the end of the function you need to return temp, okay. So this is the flow that we are going to have for this question. Let me clear it all. All right guys, so these are the steps that we followed. First of all, we had a base condition. In that you need to find out that if root is present or not, and if root is null you will simply return 0, right? Then you need to calculate for the left subtree, calculate for the right subtree, okay. So once that calculation is done, you need to make the two comparisons, right? The first comparison is when current node is a part of the diameter, and the second comparison is when the current node is not the part of diameter, right? So these are the two comparisons that we are going to do here. And once when these two comparisons are done, then in that case you can find out the final maximum value, okay, that you will store in res. And as we have passed here res by reference, okay, as you can see here we have passed it by reference, okay. So what is going to happen is res will store the maximum value, and then at the end of the main function you can simply return res, right? And then at the end of this function we are going to return temp, okay. What is temp? Temp stores the maximum of, yeah, here it is written, temp store the maximum of left subtree, right subtree plus 1, okay. All right, so is the concept clear to you all? Let me know in the chat section if the concept is not clear. And also give me a +1 if the concept is clear, so that we can move to the coding part of this question. All right, guys, can we move to the coding part of this question? Is the explanation clear, or are any further queries are there? Please feel free to write it in the chat section. Okay, so I'm assuming that the explanation is clear to you all. So let us now move to the coding part. Okay, so let me just share my screen. Okay, so as you can see here, what is happening is that the diameter is 9 nodes when we are passing through the root, and here diameter is 9 nodes when we are not passing through the nodes, not passing through the root. All right, so there can be two cases, and we have taken into consideration those two cases. This is the code for the question, and like here, this function was given to us was to find the diameter. So what we have done here is we have initialized the variable res. My screen is visible, right? All right. So in that case, it is going to be big O of n. Why? Because what we are going to do is okay. My screen is not visible because what we are going to do, what we are doing here is we are visiting to each of the nodes, right? So in that case, that is going to be big O of n. Okay, and it will be log n in binary tree. In most of the questions, it's not going to be log n because you need to visit all of the nodes, right? So in most of the cases, it will be big O of n only. In this case, also we were visiting all the nodes. Something went wrong actually. In this case, what we were doing, we were visiting through all the nodes, and then we were trying to figure out that through which nodes we are going to get the maximum diameter, right? So here the time complexity will be big O of n. So this is the code, and if there is any confusion in any part, please feel free to ask. You're welcome, Krishna. All right, guys. So if there is any confusion, feel free to ask, and if it is clear, then please do post a +1 in the chat section. Okay. So let us now move to our next question. Okay, so the second question that we are going to discuss now is, just give me a moment. Yeah, that is maximum path sum from any node. Okay, so what does the question statement read says that a binary tree is given and the task is to find the maximum path sum. The path may start and end at any node in the tree. Okay, so as you can see, an example tree is given to you. So the maximum path that we are getting here is 32. What is 32? If we sum 10, 2 and 20, okay, that is giving us the maximum path. This is the second example where the maximum path sum that we are getting is 17. Okay, and as you can see, in this case, in the first example, we started from the first node and we ended at the leaf node. All right. But in this case, what is happening? We started from the first node, but we are not going till the leaf node. Okay. It is getting terminated in the middle node only. Right. So it is not compulsory that you need to reach to the end node. You can find the maximum path sum between any two nodes of the tree. All right. So now let us just see how we can solve this question. Okay. So the second question of the day, that is max path sum from any node, right? Okay. So as all these questions are based on the concept DP on trees, so basically we are going to have the same format for all of the questions, right? Just you need to find out, there will be minute differences in the comparison part. Rest other things are going to be same. Okay. So just like the previous question, the first thing that we are going to do is, let us say this is our function int solve. We will pass the root. Okay, and as usual we will pass the answer. Okay, this res variable is going to contain the final answer of this question. Okay, and always remember, pass it by reference. Now the base case, as it was similar in the previous, as it was similar in the previous question also, the base case that we are going to have is, if not root, then we will simply return 0, right? That remains common for all the three questions. If not root, return 0. Okay, can anyone tell me what will be the second step? Very similar to what we did in the previous question. The flow remains the same. You need to write down the base case. You need to calculate for left and right subtree. You need to make the comparisons. You need to return the temp. Okay, the temporary variable that you have created, right? So now if anyone can tell me what we are going to write here next. Recursion part. Yeah, Nikas, that's the correct answer. Next, the step that you said that we will be doing after the recursion part. Okay. So let us suppose this is our tree. Okay. We need to find out the maximum path sum. So now let me first write it down. Int L, we are going to, yeah, okay, sorry, next. That's the correct thing that you have written. Actually, the function name is solver, so I got confused. So what we are going to do is, we are going to recur it for the left subtree and the right subtree. Okay. Root left res, and then we are going to do int r is solve for root right and then res. Okay, so now we will be having, let us say this is our target node in which we are working, so we will have the value for the left part, we will have the value for the right part. Okay, so these two steps are done. Next we need to make the comparisons. Okay, so now what can be the comparison? After sum of left part plus sum of right part plus root data. Yeah, that can be one of the cases, right? So see, whenever you are traversing the case, whenever you are traversing the tree, what can happen is, either you will add this node's value, okay, with its left subpart and right subpart, right? That is one thing that you can do. Or what you will do is, in temp is, yeah, exactly, next, that perfectly correct. So uh, what we are going to do is, you will need to find out that how we are getting the maximum value. Okay, there are two ways in which you can get the maximum. First of all, what it can be, that either you will find out the maximum from the left subtree, right subtree, and add it to the current node, or what you can do is, simply the current node will have the maximum value. Like, let us say if we have, say, this left subtree is giving you 30, right subtree is giving you 20, and the node is having the value of 10, right? In that case, you will add the value of left subtree plus node. Okay, but just in case, if left subtree is giving you the value of minus 25, right subtree is giving you the value of minus 16, and the node is having the value of 10, right? In that case, you are not going to add any of the values from left and right, because they are in negative and they will decrease this value. So in that case, what you will do, you will simply return this root data, right? So the comparison that we are going to do is, the first comparison that we have is, in temp, what we are going to store is maximum of. Okay, the first data that we have is find out the maximum from the left subtree, right subtree plus root data. Okay, or what you can do is simply the root data is having the maximum. Okay, I hope this case is clear when we will simply pass the root data and when we are so max root. All right, yeah, that is correct. The max is going to be what we will compare, we will store it in ans, and it is going to be what when you are passing it through this, then it will be simply either pass just the root data, or what you can do, take the sum from the left, take the sum from the right, and then add the root data in it and then pass it. Okay, so that's perfectly correct. Great, Nichols. Okay, so this is the first comparison that we are going to make, and the second comparison that we are going to have here is we have the first calculated the value of temp, and then now you need to store in ans. Okay, like it is again another variable that we have used. So what it will be having, it will be having maximum of temp, or if let us say you are passing it through the root. Okay, is it clear? This first, the third, the comparison at the number third and comparison at the number fourth, is it clear? And then at fifth you can simply have res as maximum of res and answer, and then what do we return? We are simply returning temp. Okay, temp, why? Because whatever is the value that is stored in temp, okay, that is what the maximum of one of the left subtree or right subtree plus root data, you are passing it to the root. Okay, you are telling it that okay, this is the maximum that I am getting till this point, take this maximum and proceed ahead. Okay, so that's why what we are going to do is we are going to simply return temp. All right, so are these 6 steps clear to you all? Do let me know in the chat section if these 6 steps are clear to you all. Yeah, all right. Thanks for the confirmation. Okay, so let us now move to the coding part. I will just repeat once again whatever I mentioned. What we are going to do is, this is first of all base case that we have, that if root is null, we will simply return 0. Then we are recurring for the left subtree and right subtree. Now there can be two cases. The first case can be that you are taking the maximum from either of the left subtree, from right subtree, and you are adding the current node's value to it. Okay, so this is what we are doing. You can take the maximum. As I mentioned, there can be two cases, if it is 20, 30 and 10, or if it is minus 20, minus 30 and 10. Okay, these are the value of L, R and node. Okay, so if the value of L and R are 20 and 30, what you will do, you will simply take the value from R and add 10 to it. Okay, that is this case. And but if the value of L and R are negative, so in that case what you can do, you can simply pass the value of the node. Okay, that is this case, right? So this can be one comparison, or what can be another comparison is that you can take the value from the left subtree, you can take the value from the right subtree, and then you can add it all. Okay, you don't need to find out the maximum, as I have mentioned there. Okay, so what you can do is we will do 20 plus 30 plus 10. Okay, and then we will check that in whatever case we are getting the maximum, then you need to keep the track of the maximum in every iteration and then simply return the temp. Okay, so this is the approach that we are having for this question. Now let me just share the code. So the code of this question, yeah. Okay, is the screen visible? I guess it is. So what do we need to do is, whatever is the minimum it is having, so that you can do the proper comparisons here. Okay, and then as I mentioned in the previously explained part, what you need to do is you need to find out for the left part, for the right part, then simply do the comparisons and then return temp. Okay, so that is the approach that we have for this question. And if there is any confusion, please feel free to drop it in the chat section. And also if it is clear, then please put a +1. All right. Thank you, Nikesh, for the confirmation. There are very few active people. Like as I can see, the number of participants is like more than 10 that we have currently for the live. But then there are only one or two participants who are responding. So it would be like really nice if all of you can let me know if you have any doubts or like if anything else you want to understand. So I'm always open for that. So feel free to drop it in the chat section. All right, guys. So let us now move to our next question. I'm assuming that this question is clear to you all. Okay, so just a second. Hmm. Okay. So the next question that we are going to discuss is maximum path sum between two leaf nodes. Okay. So, like, what is the difference between these two questions? The previous question that we discussed was maximum path sum between any two nodes, but this question is kind of add on to that question. Like, what you need to find out is you need to find out the maximum path sum between two leaf nodes. Okay, it is more customized format for that question. All right. So basically, what this question is expecting from us is like, let us say if this is a tree that we have, you need to find in the previous question, you could have founded the maximum path sum, if you are starting from this node or if you are ending at this node. Okay, this was also valid. But in this question, what you need to do is the maximum path sum must start from any of the leaf nodes and must end at any of the leaf nodes. Okay, so that is going to be the max path sum. Now let us see how we can approach it. As usual, what we are going to have is we are going to have our root. We are going to have a variable. Okay. And then we are going to have a base case. Right. Now, okay, if we are calculating here the maximum path sum for the leaf node, the cases that can be. Okay, so like let us say if we have taken starting from one of these leaf nodes, right? So you need to find out that whether it is passing through this current node or not. Like if you are going to involve this node or not, say if this is our target node, then you need to find out that if this will pass through like this, or if this will like if this can pass through without involving, like if it can pass through like this. Okay, and end here. Okay, always remember the ending point and starting point will always be a leaf node. Okay, now first step we are clear on this part. Second step, simply you need to find for the left part, you need to find for the right part. Okay, now let us see what we are going to do for the third step. So third, all right, so if the third step, what we are going to find out, if it is already a leaf node. Okay, the part where you are standing, that is already a leaf node. So what you will do, you will simply return its data, right? Because there are no any calculations that are needed to be done for its left part or right part, or there are no any comparisons that you need to do. So if you are already at the leaf node, what you need to do is you will simply return root data. Okay, and how we are going to check if we are at leaf node? If not, root left and not root right. Okay, so if it is a leaf node, then you will simply what we basically return at the end of every function, we are returning the current value. Okay, the current value of the node, the current value that we got after evaluating the node. Okay, Yeah, if tree is only left but not right, that case we are going to do. Okay, so we are just going step by step. I will just let you know what we are going to do in that case. So what at the end of the every function in the see in the previous functions, what we were doing, we were simply returning temp. Okay, but in this question there is one more return statement, that is return root data. Okay, what it is doing that, okay, if this is a leaf node, all right, so there is no any left subtree, there is no any right subtree. What you can do is you can simply pass on this value. This is going to be your temp only. Okay. Yeah, all right, Nikes, thanks for asking this query. We are going to take this up, okay? I will just explain in a while that what we are going to do in that case. So, all right, is this case clear that why if it is a leaf node, then we are simply passing root data? Okay, because that is going to be the current value, right? So, if it is not a leaf node, okay, now let us see what we are going to do in that case, all right? So, okay, any assumptions any one of you would like to share that if it is not a leaf node, then in that case, how we are going to do the comparisons? It is like just like the previous questions, we will have a temp, we will have a max, we will have an answer, you know, all the things will be same. So, all right, can anyone tell me what will be temp in this case? Temp is the current value that you get after evaluating the current node. Okay, let us say if you have calculated for its left part, for its right part. Okay, so what you will store in temp? Any assumptions, like anything that is coming in your mind? Like let us say this is a left part of a tree, this is a right part of a tree, and this is the current node. Okay, the current node that we are working on. So what will be the temp hold? Till max. Okay, see, basically what we hold in temp is that whatever value you are getting from left or whatever value you are getting from right, okay, you basically find out the maximum from either one of these two and then use this current node to find out the next maximum. Okay, so that's why what we are going to use in temp is just simply find out the maximum from left or right plus add the current node's value in it. Clear? What you will do, if this is a node, you will find out the value from its left part, you will find out the value from its right part, and you will add this data. Okay, and what it will contain in res is the answer that we are returning, sorry, that we will return at the end, not at the end of this function, at the end of the total function. Okay, so in res what we are going to add is basically you will write down the maximum of res. And okay, so one case it can be either you are adding L or either you are adding R. What can be the other case? So the first case is that you are taking one from the L and R. Okay, you are not taking both of them. So what can be the other case? Both, exactly, that's correct. So the other case can be that we are going to take the both the subtrees. Okay, so these are the two conditions that we have, and then we will make a comparison on these conditions. Okay, that's great, Michael, that's right answer. All right, now at the end what we are going to do is, as it was mentioned by the Nikes, that what we will do if it is only having a left part or if it is only having a right part. Okay, so if we don't have a left part, then what we are going to do is we will simply return the value that you got after calculating for its right subtree plus root data. Okay, if you do not have a left part. Okay, let us say if this is our tree. Okay, this is our tree and we are not having a left part. Okay, here we don't have a left, oh sorry, in this case we don't have a left part. Okay, so what we are going to do is simply calculate for its right. Okay, here we do have a left part. Just a second. Okay, sorry. Yeah, so in this case we are not having a left part. Okay, so what you will do, simply calculate for its right part, whatever value you are getting, add it to the current node's value and then pass it on. Okay, so and simply if you are not having a right, like in this case we are not having a right data, what you will do, simply take up this node, add this value and pass it. Okay, because that is the current value that you are going to have. Because if you are standing at this node, you need to add this node's value, right? Why? Because it is a leaf node and starting is to be done from the leaf node, so you can't skip this. And also you don't have any comparisons to make, so the only options that you are left with, you need to add this value to this value and then pass it. Okay, so if left is not present, then simply pass the sum from the right subtree, or else what you need to do is simply pass the sum from the left subtree. All right, so that is how in these 4 steps we are going to cover this question. All right, so is the approach clear to you all? All right. The playlist that you can access from the channel itself, like if you will go through that Geeks for Geeks practice channel, in that channel the playlist is there and you can access it. All the sessions are there. All right, guys. So if this concept is clear, please give me a +1 so that we can move to the coding part of the question. You're welcome, Abhijit. Okay, thank you, Nix, for the confirmation. And rest others? All right, thank you, whatever your name is. Your name is actually, I don't know how to pronounce it. All right, guys. So let us now move to the coding part. Let me just share my screen. We were discussing maximum parts in between 2 nodes. Okay. So yeah, this is the code snippet. If there is any doubt, please do. And this is the function that is passed to us. Okay. So, and then this is the recursive function that we have written. Okay. So to do the required operations, all right, you need to initialize this res with int min. Okay. And then you need to do, you need to pass it to this function. Okay. And then inside this function, you need to make the comparisons. Okay, so if there is any confusion, sir, or if there is any confusion in any of the 3 questions that were discussed today, do let me know. All right, SK, first of all, congratulations that you have started DSA. That's great. Just make sure that, stay motivated and just don't lose hope. You need to do lots of practice. So keep on practicing. All right, you can access the questions in Geeks for Geeks. We have excellent curated problems. Okay. Actually, before starting with linked list, I would suggest that you can go through the basics of the languages. And if that is clear, then you can take up the data structures, okay? Just practice is the key, all right? The more you will practice, the more questions will get clearer to you. Thank you, Naikaj, for the compliment. So, all right, guys, there are 3 more sessions that are left. Tomorrow we will be discussing on tomorrow we will be discussing on MCM. Okay, and after that the 2 more sessions that we will be taking, that in that we will do some practice questions. All right, so that is how the series is going to end. Or if there is anything that you want me to add, you can let me know that. Okay, so SK, if you have done the basics, then that's great. You can start from the data structures, just keep on practicing. Okay, start from easier questions and then keep on leveling up. Okay guys, so can I please get a +1? Yeah, MCM is actually super confusing. I will try to make it easier for you. You're most welcome, Nix. Yes, Abhijit, every Thursday and Friday we have sessions at 10 p.m. only. And then we have other sessions on Mondays and Tuesdays as well. So make sure to attend as many sessions as you can. Right now we are having on Mondays and Tuesdays, we have sessions for SD preparation. The questions that are covered there, okay? All right, guys. So I hope the questions were clear to you. I was able to clarify the concepts for you. Thank you everyone for attending the sessions and see you all in tomorrow's session. Take care everyone, stay safe and keep up the hard work.